All right, so if we look at problem number 1, 2 to the x equals 5. So right away we can see that base 2 and base 5 are never going to be the same. You can't change 5 to a base 2. It doesn't exist. But we can see that if we approximate what the answer should be, you can just plug some numbers in for x. 2 to the first is 2, 2 to the second is 4. We're getting close to 5. 2 to the third is 8, so now we're over 5. So we know the answer has to be somewhere between 2 and 3, some decimal. And so we want to find the exact answer. So instead of just guessing and checking and plugging numbers in, we can actually use some algebra to do it for us. All right, so here's the steps that we're going to use to solve it. So if you can't get the bases the same, okay, this is the technique we're going to use. If you can get the bases, then use the technique that we used yesterday. All right. The first step, always try to isolate that b to the x term, right? So the base to the exponent. If there's a number that's being multiplied in front or added or subtracted at the end, not up in the exponent, but just added or subtracted at the end, you got to move all that stuff over to the other side. Okay, that's step 1. Then we're going to change it from an exponential equation to a log equation. So we're going to change the form, right? So we're changing it from exponential form into log form. Once we change it into the log equation, we can get x by itself if it's not, and then we can use the change of base formula, right? And we can get the decimal answer. So this is why we learned how to use the change of base formula to solve these kind of problems. All right, so number 1, we're going to just go straight to changing it from exponential form to log form. Right, so this would be log base 2, 5 equals x. All right, now x is already by itself. And some of your calculators, you can, I know some of your calculators, you have a little subscript next to your log that you can use, and that's okay. So this is an exact answer. But what we're going to do is use the change of base formula to give the exact answer because most calculators can't do that. And so the change of base formula would be log 5 over log 2. All right, so this is our exact answer. I know it looks weird, but that is the answer for x. That if we raise 2 to this power, it's going to equal 5. All right, now, that doesn't really mean anything, so we're going to go ahead and find the decimal answer. And so we take our calculator and then put in log 5 divided by log 2. And with these decimals, we're going to go ahead and just round to 3 decimal places, so the thousandths. And so you should get 2.322, I believe. All right, so you want to practice using your calculator, rounding to 3 decimal places. All right, number 2. 5 to the x equals 11. So we can see base 5 and base 11, you're never going to get them the same. So we have to use this log form. All right, so this would be log 5, base 5, 11 equals x. All right, x is already by itself. So the log, using the change of base formula, log 11 over log 5. All right, so this is our exact answer. And then we'll go ahead and put it in the calculator and get the decimal. Go 3 decimal places again. So we'll go 1.4, and then 89 is going to have to go up to 90. So 1.490. All right, number 3. So here we have that 12 to the x, but then there's a plus 2 on the same side. So we have to isolate that 12 to the x term. So we're going to subtract 2 on both sides. So that's 8. And now we can change it to a log equation. So log base 12, 8 equals x. It's going to be log 8 divided by log 12. And then we can give the decimal answer also. So 0.837. right, number 4. We have a 2 in front of the 5 to the x, so we have to get rid of the 2 first. And since it's being multiplied, we can divide both sides by 2. Okay, you can't multiply 2 times 5 and make it 10, but you can get rid of the 2 by dividing it. All right, and then we'll go to log form. Okay, so log base 5, 8 equals x. Change of base, log 8 over log 5. And we'll give the decimal 1.292. All right, number 5, we're going to go straight to log form. So you can have something added or subtracted or multiplied up in the exponent position. Again, you just can't have anything be multiplied in front of the base or added or subtracted to the base. Got to move all that stuff over. All right, so then we'll go to log form. So log base 11, 15 equals x plus 2. All right, now you have to be careful here. So when we have to get x by itself, so we got to subtract the 2 over. When you subtract 2 over, you're not subtracting 2 from 15 to make it 13. You're subtracting 2 from the entire log. Remember, this is just some decimal, okay, that you're subtracting 2 off of. So what I would do is I would convert this to the change of base formula first, then subtract that 2 over, so it will keep you from trying to subtract it off of that 15. Right, so log 15 over log 11. Okay, now I'm subtracting 2 over. So it looks like that. So log 15 over log 11, that's some decimal, and then we'll subtract 2 off of that decimal. All right, so decimal negative 0.871, I believe. Yes? So the other way you could do it, like you could rewrite it as log 11, base 11, 15 minus 2. So if you have a calculator that allows you to put a subscript in, then you could write like that. So you're doing this log part first, okay, and then minus 2. So just check on your calculator. Some of your calculators, if you're doing this, you may not need the parentheses. You just have to be careful that it doesn't try to make it 13. That's why I just throw the parentheses on there. But try both ways. You have your calculators. As long as you get this decimal, then it should be okay. All right, so let's start over, number 6. All right, so now we have a e as our base. All right, so again, it's being multiplied to 3, so we're going to divide that 3 over first. So e to the x equals 4. Now we're going to change it to a log. All right, so this is log base e 4 equals x. Now, anytime e is the base, you're not going to use the change of base formula because log base e is special. What's log base e the same as? What is it? Not log. No, just what's log base e? ln. So we can rewrite this as ln4. All right, so ln4 is the exact answer. And we have an ln key on our calculator that we can use. Okay? So instead of using the change of base, we can rewrite it as just ln4. All right, and then the decimal, 1.386. All right, 7. Let's see, we got a lot of stuff that we got to move over. So the first thing we're going to do is add 6 over. It's going to be 25. Then we're going to divide by 2. Now, when you divide by 2, if this comes out to be a decimal that goes on forever, then you have to leave it as a fraction. Okay? If the decimal stops and you want to write it as a decimal instead of a fraction, then that's fine. You can work with fractions, it's fine. Okay? But you can also, if you wanted to work with decimals, as long as the decimal stops. Okay? Because if it goes on forever, then you're trying to round in the middle of a problem, and we only round one time, and that's at the very end. So don't try to round in the middle. So again, if this goes on forever, just leave it as the fraction, 25 over 2. But this decimal does stop, so it's easier to probably work with decimals if you can. So we can just convert that to 12.5. All right, and then let's go ahead and change it to a log. So log base 5, 12.5 equals x plus 3. And then we're going to subtract the 3 over. We can use the change of base on this. Okay, so log 12.5 over log 5. And we're subtracting 3 over. All right, and then the decimal, negative 1.431. You can't have negative answers with this. All right, 2 more. Number 8. So we have that half in front. So what would we do with that half? Yeah. Okay, you can divide by half. What's another thing that we could do instead of dividing? Yeah, Leo? Multiply by 2. Yeah, so we could multiply by the reciprocal. There's nothing wrong with dividing by half, but if you struggle with taking something and dividing it by a fraction, then don't do that. Multiply by the reciprocal instead. So we can multiply both sides by 2. All right, so e to the x minus 5 equals 16. All right, and log base e 16 equals x minus 5. Log base e is ln 16 equals x minus 5. You can add 5 over. Okay, be careful when you add 5. You're not adding 5 to 16. You're adding 5 to ln 16. So some of you may want to put this ln 16 in parentheses and then put the 5 on the outside. Another way you could do it is put the 5 in front and show you're adding it to ln 16 like that. It's the same thing. Okay, so either one. And then let's go and give the decimal 7.773. All right, number 9 is starred because this is the one that's the hardest out of all of them. I would say this is probably the hardest problem in the entire Unit 8 or Unit 7 combined. All right. So we don't have, the bases can't be made the same, you have 5 and 8. And there's variables on both sides. So this is what's different about, on this problem as all the other problems that we've done. All the other ones, there was only one variable on one side. This has variables on both sides. So we have to use a different technique. You can't just go straight to a log equation. So we're going to use this second technique that's in here. And instead of changing it to log form, we're going to log both sides instead. Okay, now this technique, logging both sides, could be used on all of these other ones also. I just didn't show it. just because I think it's easier to just change it into a log equation rather than using the second method. Okay. So the second method is the only one I would use on this type of problem where you have x's on both sides. All right, so you want to see how to set this problem up. All right, so what we're going to do is log both sides. So that just means that we're putting log in front of both bases. Okay, so what you do to one side, you got to do the other. All right, then the second step is to take your exponents and you're going to move them down in front. This is the power property that says that when you have a log expression and you have an exponent, you can move it down in front. Now, if the exponent is a binomial, when you bring it down in front, you want to put parentheses around it, and I'll show you why in just a second. If it's not a binomial, then you don't have to put parentheses on it. All right, then the next step is you're going to take your logs and you're going to distribute inside to both terms. Okay, we're going to do that on both because we have two binomials. So when we distribute the logs in, the terms that are inside the parentheses are the numbers or the coefficients in front of both logs when you multiply it in. So when we take that log 5 and we distribute it into the x, it becomes x log 5. That's x times log 5. And then plus, and then we distribute log 5 to the 4, it becomes 4 times log 5 or 4 log 5. All right, and then we're going to do the same thing to the right side. So x log 8 minus 3 log 8. All right, the next step is to get all the x logs on one side and all the logs that don't have x's on the other side. Doesn't matter which side you want to move things to. You can move everything on the left side, all the x's on the left side, or move all the x's on the right. Doesn't matter. All right. So we're either going to subtract this x log 5 over here and bring this, we're going to add 3 log 8 over here, or we're going to subtract the x log 8 over here and then subtract the 4 log 5 over here. Okay? So what I'll do is, just so I can get rid of this negative, but it doesn't matter, I'm going to subtract x log 5, bring it on this side, and add 3 log 8. Now I'm not combining any of these things, I'm just moving them over. All right, so 4 log 5 plus 3 log 8 equals x log 8 minus x log 5. All right, so I think we have just 2 steps in here. So now once you have the x's on one side, you're going to factor the GCF out, which is x. They both have x's, you're going to factor x out. All right, so I'm just rewriting the left side here. All right, and then really the last step is just divide both sides by this log 8 minus log 5. So this is the exact answer for x. Now, the reason why I'm using parentheses on the bottom one is because most of your calculators, when you go to get the decimal, if you don't put parentheses around this, then what it's going to do is this top part divided by log 8, and then it's going to subtract log 5 off to the side, rather than doing this whole thing in the denominator. So use parentheses. I know some of your calculators, you have multiple screens on there, so you can probably just type it in exactly the way you see it, like this. All right. So go ahead and try it. Get the decimal. Okay, and we'll see if you input it in the calculator correctly to get the decimal.